Hello, I welcome you all to this another interesting screencast, and the problem reads determine the moment produced by force B about point O, force C about point O, and force B and C about point O. And we are to express the result as a Cartesian vectors. Problem is coming from the engineering mechanics statics textbook. Right, so we have two forces from point A supporting this particular cantilever beam or supporting this column, and we are being asked to determine the moment about point O due to FB, later on due to FC, and then later on due to a combination of FB and FC. Right, so we are going to use the vector analysis method, where I will say moment is equal to R moment arm cross F. Okay, so both are vectors and the resultant moment is also a vector moment. All right, so what we need to do is to convert both forces into vectors and to also find the moment arms. All right, so we have for the moment, due to moment about point L due to FB, we have two possible moment arms. We have this one, this is RB, or we can also use this one, RA. Okay, then for moment due to FC, we have also two possible moment arms. We have this one, RC. We also have this one again RA. Okay, and then for moment due to FC and FB, of course, we can sum up moments. We can sum up, so we can have due to FB and FC, we can either use RA itself, moment here we can use RA cross FB plus FC, or we can say moment itself is equal to RB cross FB plus RC cross FC. But for us, we just go with one moment arm. Why have the trouble separating this? We are just going to pick one moment arm, which is just RA. Okay, I mean, go for the easiest, or the one that has less pressure, right? Because no one wants pressure. We all want the easy way, but of course the easy way has to always make sense, right? Great, so we have that. Let's find the coordinates quickly. Coordinates for A, T just 0. Of course our reference is all 0, 0, 6. Reference for B is 0, 2.5, 0, and the coordinates for C is a 2, -3, 0. Okay, let's find RA. RA is just going to be equal to 6K. Let's find RB. We need all of these. Why? Because we need to find the unit vector along AB and AC, which will help us convert those forces into vector forces. RB is equal to just 2.5J. and RC is equal to 2I minus 3J. Okay, great. Let's move on to another stage where we find the unit vectors. Let me rub this unit vector. So let's start with unit vector AB. Unit vector AB is equal to RAB divided by its magnitude. Okay, and this is equal to RB is just B minus A, 0 minus 0, 0, 2.5 minus 0 is 2.5, J, and then 0 minus 6 is just minus 6K. And then the magnitude of this, just grab your calculator, use Pythagoras. 2.5 squared plus 6 squared, square root of that, that's 6.5. We found the unit vector for direction AB. Let's find the unit vector for direction AC, and this is equal to, these are vectors, this is RAC divided by its magnitude, and this is equal to C minus A for the coordinates, 2 minus 0, that's 2I, and minus 3 minus 0, that is minus 3. Okay, 0 minus 6, that's minus 6. Then divided by, that's 2 squared plus 3 squared plus 6 squared. So divided by 7, like so. Great. So we have this. Let's convert the forces. Let's start with force FB, converting it to a force vector. This is going to be equal to its magnitude times the unit vector UAB. Right? This is equal to 780 times the unit vector 2.5 divided by 6.5 minus 2.5 divided by 6.5 J minus 6K divided by 6.5. Let's multiply 2.5 divided by 6.5 times 780. This gives us a 300J. Okay, minus 6 divided by 6.5 times 780. This gives us a 720K. Alright, let's convert FC into a force vector also. So we are multiplying FC, this magnitude, by the unit vector UAC. This is equal to, as a magnitude is 420, and what's the unit vector? It is 2I divided by 7 minus 3J divided by 7 minus 6K divided by 7. Okay, 2 divided by 7 times 420. So we have a 120I minus 3 divided by 7 times 420. This is 180J minus, let me just write this properly. This is 180J. Then minus 6 divided by 7 by 420. This is a 360K. Alright, then let's sum up FB plus FC. we'll use this in the third case. We need to sum up the two. So FB is 300J minus 720K plus the other one, which is 120I minus 180J minus 360K. Okay, so for the I, we have 120. We'll have 120 for I. We'll have 120I. And then for the J, 300 minus 180. We'll have plus 120J. And then minus 720. Both minuses. So minus 1080K. Okay. So we found at least what we need for now. Let's go to case 4-32. Case 4-32. That's our first case. So what are we finding here? This is a moment due to FB, right? So moment due to FB, this is going to be equal to RA cross FB. Okay, so we have I, we have J, we have K. So we have RA there 006, and then we have FB. What is FB? FB, we found it as 300 then minus 720. Okay, then in the I direction, what do we have? We have a minus 1800. Okay, then minus J, what do we have? We have a 0. Okay, then plus K, what do we have? We also have a 0. Therefore, MO due to FB is just going to be equal to minus 1800 I. Okay, Newton meters. All right, then let's move on to case number 2, which is 4-33. This is moment due to FC. So what do we have here? We have moment due to FC. Let's work it out. So this moment, which is a moment vector, is just equal to also RA cross FC, and this is equal to, let's plug it in our 2. Okay, so we have 006. What is FC? FC is 120 and minus 180 and minus 360. This is equal to I. What do we have? I, that's a plus, that's 6 by 180, 1080 minus J. What do we have? Minus 6 by 120 That's minus 720. Okay, then plus k, we just have a 0. Therefore, this moment due to FC, moment about pointer due to FC, is equal to 1080 I, okay, plus 720 J, okay, 720 J, right, and the units are Newton meters. Okay, then finally case 4-34. This one is moment due to FB plus FC, right? All right. So we have moment vector. This is going to be equal to RA cross FB plus FC. Both we are summing up two force vectors. This is going to be equal to, let's open up our tool. We have I, J, K. Okay. Let me just write this. We have I, J, K. Okay. So this is 0, 0, 6. And then FB plus FC. We have a 120, 120. And then a minus 1080. This is equal to, in the ith direction, we have 120 by 6, which is a minus 720, right? And minus J, we have another minus 720, then plus K. Okay, we have a 0. Therefore, this moment vector, the moment vector is just going to be equal to minus 720 I plus 720 J. Okay, and this is Newton meters. Alright, so let's just outline the final solutions. We have the first case. This is moment due to FB about point O. We have the second case. This is moment due to FC about point O. And finally, we have moment due to FB plus FC. Okay, so this is about it, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.